So let's do some problems. Calculate the average speed in miles per hour of a person who runs 3 miles in 20 minutes. To calculate the average speed in miles per hour of a person who runs 3 miles in 20 minutes. Anyone get an answer? Say it. Anyone get something besides 9? Who got 9? Only one person got 9? Anyone get anything different? What'd you get? So, the speed, put 5 numbers. So, speed equals distance over time. This would be our distance in miles. And this is our time in minutes. How would we convert 20 minutes into hours? Multiply it by what? So 20 minutes is equal to 60 hours. So No, because it wants it in miles per hour. So 20 minutes. If you look at the clock and go 20 minutes over, what percentage of an hour is 20 minutes? It's 1/3 of an hour. So it should be equal to 0.333 carried hours. So 20 minutes, we know that there are 60 minutes in 1 hour. So we do, to cancel out minutes, we do 20 divided by 60. So 20 minutes is equal to 20 divided by 60 hours, or 0.333 carried hours, or 1/3. So our distance is 3 miles divided by 0.333 carried hours, and you should get 9 miles per hour. Let's see. So, where's a good example? So let's do this. A ball rolls down a hill gaining 5 feet per second squared. If the ball's initial velocity is 10 feet per second, how long does it take the ball to reach 30 feet per second? So a ball rolls down a hill gaining 5 feet per second squared. If the ball's initial velocity is 10 feet per second, how long does it take the ball to reach 30 feet per second? So a ball rolls down a hill gaining 5 feet per second squared. If the ball's initial velocity is 10 feet per second, how long does it take a ball to reach 30 feet per second? To reach a speed of 30 feet per second. Our velocity. So let's list our variables. Feet per second squared. It's going to be your acceleration. Feet per second squared. Initial velocity is 10 feet per second. How long does it take a ball to reach 30 feet per second? So that would be its final velocity of 30 feet per second. So we know that our equation for acceleration is equal to final velocity minus initial velocity over time. We're solving for time. So time would equal final velocity minus initial velocity over acceleration. So that would be 30 feet per second minus 10 feet per second over 5 feet per second squared. Which would equal 4 seconds. So if you're gaining 5 feet per second every second, and you start out traveling every 10 feet for every second, and how long would it take you to where you are starting to move 30 feet for every second? You are gaining 10 miles per hour every minute. What would be your change in velocity after 20 seconds? No, let's make it after 15 seconds. So you're gaining 10 miles per hour every minute. What would be your change in velocity after 15 seconds? So what'd y'all get? And put your phone up during lecture. Put your phone up during lecture. So what'd you get? So this is your acceleration. So your acceleration is 10 miles per hour per minute. Another way of writing miles per hour is 10 miles per hour per minute. Or time is 15 seconds, but we're dealing with minutes for our acceleration, so we need to convert this. So 15 divided by 60 would give us minutes, so that would be equal to 0.25 minutes. Acceleration, VF minus VI, T. So we're solving for change. So change, the VF minus VI is equal to A times T. Our acceleration was 10 miles per hour divided by minutes times 0.25 minutes. Minutes will cancel each other out, leaving us just with miles per hour. So 2.5 miles per hour. Your speed changed by 2.5 miles per hour. You gained, this means you gained 2.5 miles in 15 seconds. If your acceleration is 10 miles per hour over a minute, that's the same thing as 2.5 miles per hour in 15 seconds. Let me see if I can find another. So the purpose of me showing you this is units. I know I do a lot of my examples in meters per second and meters per second squared, but we can use any units. We can use feet, we can use miles, we can use minutes, we can use hours. I'm trying to think if we have. Is everyone comfortable with this? It's the same thing we've been doing. Everyone good? Yes. So I'm going to be passing out homework. That's really cool. Very important. Rows always top. So take the top page, go down a row, to the next row,